All right, so we're going to graph these parabolas. I'm missing a little something here. Should have a y equals. All right, so we'll go ahead and graph this. And to do so, I kind of need this key information right here. It'll make it a lot easier. So it is in vertex form, and so my vertex is at 3, 4. Because if you were to plug in a 3, the y value would equal that 4 right there. So that's what's taking place there. And that will actually make this the highest point on the graph. And so it's a maximum point because that negative right there, anything other than 3 that's plugged in is going to result in a negative value once you square it, and then the negative gets applied. So basically our parabola should open down like that, just like that. The axis of symmetry is just x equals 3. It's just basically what that does is it cuts the parabola in half right there. And so it's the x value of the vertex that does that right there, x equals 3. Okay, and we can go ahead and plot those points, or the vertex and the axis of symmetry. So I'm right there, and my axis of symmetry cuts right through it. Okay, so it's going to open down, and so we have to find those x-intercepts. And so the way we're going to do that is let y equal 0. So we're going to have 0 equals negative parentheses x minus 3 squared plus 4. And we're going to subtract 4 from both sides. This is one way to do it. I think I did it differently in class when we covered this topic, but it's all going to work out because the reason I did it this way is a lot of times students get to this point and they get a little confused. They think that their answer is, complex numbers. They're going to have like an I involved or something, but that's not the case. Actually, what you'll do here is divide by -1 because you have a negative in front of the parentheses right here. So then we're going to end up with 4 equals parentheses positive parentheses x minus 3 squared. Now we'll go ahead and square root both sides, and so we have to put that plus minus right there. So let's see, if I can put this over here. So we're going to end up with x minus 3 is equal to plus minus 2. And so we'll go ahead and add the 3 to both sides. X equals 3 plus minus 2. So when you add 2, you get a 5. And when you subtract 2, you get a 1. So those are my two x-intercepts. So I have one here at 1 and at 5. And you'll notice that that line of symmetry is equal distance from both of those points right there. Okay, you could probably draw it the way it is, but we might as well find the y-intercept. Find the y-intercept, and then you can reflect that point across the axis of symmetry, and we'll have quite a few points to graph this. So for the y-intercept, basically you're going to have to evaluate the function at f of 0. You're letting x equal 0 in this case. So we're going to have negative parentheses 0 minus 3 squared plus 4. And so we get negative 3 squared plus 4. And so when you square the -3, it does turn into a +9, but it has that negative waiting for it. So we end up with -9 plus 4, which is actually -5. So my y-intercept is at 0, -5. So it's going to be right here. And we can go ahead, let's see, it's 1, 2, 3, so go 1, 2, 3 past it. And now we'll go ahead and draw this. You want to draw it with bowl shape, smooth curves. Don't do a V shape, okay? And there you go. Okay, so I have one more of these, but it's going to be in a different format. And once again, I forgot the y equals part, but we'll go ahead and put that on there. So let's see, y equals, okay, now we're looking at not just an expression, but an equation we can graph. Okay, so you could manipulate this and put it into vertex form, but instead there's a little formula I showed y'all where you can do x equals negative b divided by 2a, and that'll give you the x value for your vertex. Once you do that, then you can plug that value in to figure out the y value of the vertex. All right, so this is your a, this is your b value right here. So we're going to have negative 4 over 2 times 1. So we're going to end up with positive 4 over 2. This then simplifies to a 2. So I know the x value is 2. Now I just have to plug that in to figure out the y value. So I'm going to use function notation here. So I'm going to do f of 2 and plug that in. So 2 squared minus 4 times 2 minus 5. So 2 squared is 4 minus 8 minus 5. So 4 minus 8 is negative 4. Then minus 5, that's going to give us a negative 9. Negative 9 is going to be the y value for my vertex right there. So I'm at 2, negative 9 down here. Okay. This is going to be a minimum because it's going to open up. And the reason I know that is because my a value is positive. So right there, you can even think about this as your in behavior. Because as you think about as x increases to infinity or goes to negative infinity, when you square it, you get a positive result, and these other numbers aren't going to really affect it. So in the long run, it's going to go up as you go towards infinity and negative infinity on the x-axis. Okay, axis of symmetry, just like the other one, it's just going to be a x equals 2. To find the x-intercepts, this time this is going to be factorable. So we're going to have x squared minus 4x minus 5, and we'll set that equal to 0. And that should factor into minus 5 and plus 1. So that puts my intercepts at positive 5 and negative 1. Okay, and let me draw my axis of symmetry, and we'll see that those those x-intercepts are equal distance from my axis of symmetry. 5 right there. So you can see that they're equal distance from the axis of symmetry. Okay, so now the y-intercept's super easy, because if you let x equal 0, then it's going to simplify just to negative 5 right there. So that's what it simplifies to when you let x equal 0. So let's see right here. Then we can go ahead and reflect it across over here. All right, now we'll go ahead and draw this parabola opening up. There we go. Let's see, the range is going to be from negative 9 to infinity. Now that I think about it, I think I forgot to do the range up above. So we'll go up there and do that real quick. Okay, so the range on this one is going to be from negative infinity up to a 4. Oops, bracket that 4. There we go. From negative infinity up to 4.